Hey guys, tonight we're going to venture into a very strange and beautiful place. Imagine with me for a moment that you're standing on the edge of a deep crater, the air thick with the smell of sulfur and ancient rock. Below you, a searing glowing liquid churns a molten heart beating deep within the earth. This isn't a place you can survive, of course. The heat would melt your bones long before you even got close, and the gases would steal your breath away. But tonight, we will go there not with our bodies, but with our minds. We will ask a seemingly simple question that has vast and complex echoes. What if we dumped all of our trash into volcanoes? So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And as we begin our journey, I'd love for you to share where you are in the world right now and what time it is, so we can feel a little more connected as we drift into the quiet. Now let us begin our descent into the deep. The idea at first feels almost elegant, a problem solved by a natural wonder. The volcano, that great all-consuming mouth of the earth, seems like the perfect solution to our endless stream of waste. We imagine it as a cosmic incinerator, a furnace so hot and powerful that it could simply erase our plastic bottles, our broken phones, our discarded furniture, and all the rest. It's a compelling fantasy, born from a desire to find a single powerful answer to a monumental global challenge. But as with all things in science and history, the simple answer is rarely the correct one. The truth is far more intricate, more surprising, and perhaps even more poetic. To understand why this seemingly brilliant idea is so deeply flawed, we must first go back to the source, to the very nature of a volcano itself. We need to understand what that swirling, glowing liquid actually is, and what happens when you introduce something completely foreign into its ancient, fragile world. Let us think of the Earth not as a solid, static ball, but as a living, breathing entity with a complex circulatory system. Beneath the crust, which is just a thin, brittle skin, lies the mantle. The mantle is a place of immense heat and pressure where solid rock behaves less like a stone and more like a thick, slow-moving liquid over geological timescales. This is where magma is born. Magma isn't just molten rock. It's a dynamic superheated mixture of liquid rock-dissolved gases and mineral crystals. The temperature can range from around 700 degrees Celsius to over 200 degrees Celsius, and it's a world of unbelievable chemical potential. This extreme heat and pressure are the two core concepts we must hold in our minds. The sheer power here is difficult to grasp from a human perspective. We think of our furnaces and incinerators as being hot, but they are like a child's candle flame compared to the sun that is a magma chamber. The pressures are equally immense, with rock being crushed and reformed into new substances under the weight of the entire planet above it. This is a beautiful and often overlooked detail about our home. The Earth is constantly recycling itself. The rock that makes up the ground you walk on today may have been deep within the mantle millions of years ago, a silent, swirling participant in the planet's slow-motion ballet. This process is called the rock cycle, and it's a core concept of geology. Igneous rock forms from cooling magma, or lava sedimentary rock forms from the accumulation of sediments, and metamorphic rock forms when existing rocks are changed by heat and pressure. The volcano is our most dramatic window into the igneous part of this cycle. It is a portal, a place where the Earth's inner workings are briefly and violently exposed to the surface. And within this powerful natural cycle, every element, every mineral has a role to play. There is a kind of inherent logic and elegant simplicity to how it all fits together. There is no waste, only transformation. And so we arrive at our problem. Our trash, our plastic, our glass, our metal is entirely alien to this system. It has no place in the rock cycle. It is a product of human ingenuity. Yes, but it is also a testament to our profound disconnect from the natural processes that sustain our world. We have created materials that nature on its own has no way of processing or reintegrating. Consider a simple plastic bottle. It's made from polymers, long chains of molecules, derived from petroleum, which is essentially the fossilized remains of ancient life. The volcano, in its wisdom, knows how to handle a tree trunk or piece of organic matter it burns, it releasing the carbon and other elements back into the atmosphere and leaving behind simple ash. But the plastic bottle is a different story entirely. It is a complex synthetic puzzle piece that does not fit into the geological picture. There is a fascinating and little-known scientific fact that illustrates the incredible power of these systems. Did you know that some deep-sea volcanic vents, far below the surface of the ocean, are home to entire ecosystems that do not rely on the sun for energy? This is known as chemosynthesis. Instead of photosynthesis, these organisms thrive on the chemical energy released by the hot mineral-rich water spewing from the vents. It is a secret hidden world, a testament to the Earth's ability to find a way to create life in the most inhospitable conditions. This tells us something profound about the Earth's natural state. It is not a passive host for life. It is an active creative force, a place where even the most destructive processes like volcanism can give rise to new, unique forms of existence. It raises a beautiful and humbling question. What other hidden worlds, what other secret chemistries are taking place deep within the mantle right now, far from our knowing eyes? The truth is, we don't really know for sure what all is going on down there. We can only infer from what we see at the surface. So when we consider our trash, we must see it not just as waste, but as a collection of foreign uninvited guests into this delicate and ancient system. The moment our first plastic bag or used battery tumbles into that searing mouth, it is not simply destroyed. It is, in fact, beginning a new, unpredictable, and potentially disastrous chemical journey. We are not feeding a fire. We are introducing an unwelcome variable into a complex, finely tuned chemical equation that has been in place for billions of years. We are attempting to force our brief artificial existence into the deep geological memory of our planet, and the consequences of that action are not what we imagine. This single act would not simply erase our problem, it would transform it, give it a new and more insidious form, one that could ripple outwards and upwards to touch every part of the living world we inhabit. Our journey has just begun, and it will take us not just deeper into the earth, but higher into the sky and far, far into the future. Last time we began to think about the volcano, not as a simple pit of fire, but as the fiery beating heart of a complex and ancient planet. We talked about magma as a sophisticated chemical soup, a world of immense heat and pressure that has been in a slow, elegant dance for billions of years. Now let's imagine what happens when we throw something from our world, something utterly alien, into its midst. Let's take the most common and persistent of our modern creations, plastic. A simple, ubiquitous plastic bottle. We see it as a nuisance, a symbol of our waste problem. The volcano, however, would see it as a foreign invader, a complex and unstable collection of hydrocarbons that does not belong. The interaction would be less a destruction and more a chaotic, violent, and messy transformation. When that plastic bottle hits the surface of the lava, it would not simply melt away. The temperatures in a magma chamber are far, far higher than what's needed to melt plastic. Instead, the intense heat would cause an immediate and violent process of decomposition. The long polymer chains that make up the plastic would rapidly break apart. This isn't a clean, silent process. It's a chemical explosion, a swift and furious transformation that would release a cocktail of new compounds and gases. Think of a plastic bottle not as a solid object, but as a dense packet of chemical energy. When we throw it into the volcano, we are essentially unzipping that packet at an incredible speed, releasing all of its contents in a rush. This brings us to a core concept in chemistry pyrolysis. This is the thermal decomposition of materials at high temperatures in an oxygen-free environment. In an open fire, plastic burns, but it also combines with oxygen in the air, creating a different set of byproducts. Deep inside a volcano, where oxygen is scarce, the process would be different. The hydrocarbons in the plastic would break down into simpler compounds, including methane carbon monoxide and a host of volatile organic compounds. But it would also release something far more sinister: dioxins, furans, and polychlorinated biphenyls, or PCBs. These are not just common pollutants. They are highly toxic, persistent organic pollutants that have no place in our planet's natural systems. They are known carcinogens and have long-term effects on the environment and on all life, from plants to animals to humans. The immediate reaction would be a sight of both terrible beauty and profound danger. A cloud of black smoke would billow from the crater, thick and oily, carrying these toxic compounds high into the atmosphere. This wouldn't be the clean, simple plume of a natural eruption. It would be a plume of our own making, a irrevisible and poisonous testament to our failed attempt at a quick fix. And remember, the plastic we're talking about is just one part of the problem. What about all the other things in our trash? The heavy metals in our electronics, the batteries with their complex chemistry, the paints and chemicals in our discarded household goods. Each of these would react with the intense heat and pressure in their own unique and unpredictable ways, creating a new, ever more dangerous chemical soup. The beautiful simplicity of the Earth's rock cycle, which we talked about earlier, is about the transformation of natural minerals and elements. It's a closed loop where everything that comes from the Earth eventually returns to the Earth in a different form. Our trash, however, introduces an open-ended problem. It introduces things that don't have a natural end in this cycle. These toxic compounds, once released, don't simply disappear. They travel. They are carried by wind and water, settling on land in rivers and eventually in the deepest parts of our oceans. They enter the food chain, building up in the tissues of plants and animals through a process called bioaccumulation. A small fish eats a tiny particle, then a bigger fish eats that small fish, and so on, until the concentration of toxins is magnified to dangerous levels at the top of the food chain. This is a quiet, invisible violence that would ripple out from our volcanic solution for generations. There's a curious and little-known fact that highlights just how delicately balanced these systems are. Geologists have found that certain types of ancient volcanic eruptions, known as large igneous provinces, have been linked to mass extinction events throughout Earth's history. These massive eruptions released huge amounts of gases and aerosols that fundamentally changed the global climate. The Earth has a natural capacity to process and integrate a certain amount of change, but when a threshold is crossed, the consequences are catastrophic. By throwing our synthetic waste into a volcano, we are not just creating a local problem, we are introducing an entirely new variable into this already sensitive planet-sized equation. We are essentially forcing a miniature man-made mass extinction event on ourselves, a slow toxic-laced version that would play out over decades rather than years. This raises a fascinating and humbling question for scientists and philosophers alike. Is the Earth a self-healing organism with an infinite capacity to absorb our mistakes, or is it a fragile system with a breaking point we have yet to find? The truth is, we don't know for sure where that line is. We are in the strange position of being both the most intelligent species on the planet and perhaps the most reckless. The very act of asking the question, what if we dumped our trash into a volcano, shows our desire for a final clean answer. But the reality is that the universe and our planet prefers to transform rather than to simply erase. Our trash would not be erased by the volcano. It would be reborn, reshaped into something new and terrible, a lasting legacy of our fleeting synthetic age, and its story would just be beginning. We've begun to understand that the volcano is not a cosmic trash bin, but a complex chemical crucible. We've seen how our plastics, upon meeting this fiery embrace, would not simply vanish, but would break down into a plume of toxic, unseen compounds. But the story doesn't end there for a volcano's power. is not just in its heat and its lava. It is also in its breath. The Earth breathes, and its exhalations are the gases that emerge from deep within its core, a silent and constant conversation between the planet's interior and its atmosphere. When we add our waste to this equation, we are not just altering the ground, we are altering the very air that sustains us. A volcano, even when it is not actively erupting, is a constant source of gas. These volcanic gases are a natural and necessary part of the Earth's atmosphere. They are primarily composed of water vapor, carbon dioxide, sulfur dioxide, and hydrogen sulfide, among others. These are the planet's natural byproducts, the exhaust of its geological engine. They play a crucial role in shaping our climate and even over the long term in creating and replenishing our atmosphere. The sulfur dioxide, for example, can combine with water vapor to form sulfuric acid aerosols, which reflect sunlight and can lead to a temporary cooling effect on the planet. This is a natural, albeit powerful part of the Earth's checks and balances. Now imagine our plastic bottle again, or a pile of discarded tires, or a mountain of old computers and phones. As we discussed, they would be broken down into a new complex assortment of gases. This is where we must introduce another core concept, volatiles. Volatiles are chemical substances that can be easily vaporized or turned into gas at relatively low temperatures. The natural gases of a volcano, like carbon dioxide and water vapor, are Earth's own volatiles. But the gases released from our synthetic trash, the dioxins, furans, and methane, are entirely new volatiles, a man-made addition to this ancient natural system. And they would not be simply diluted and lost. They would be carried by the very force of the volcanic eruption, shot high into the stratosphere, where they could linger for years, if not decades. This is where the story becomes even more unsettling. The stratosphere is a layer of our atmosphere that is incredibly stable. There is very little mixing of air between the stratosphere and the lower layer, the troposphere, where we live and breathe. When our toxic gases reach this high altitude, they become trapped. They would form a persistent global blanket of pollution. And these aren't just benign compounds. The methane, for instance, is a far more potent greenhouse gas than carbon dioxide, trapping heat in the atmosphere with much greater efficiency. The other compounds would slowly break down, but as they do, they would release other pollutants that could have unexpected and long-lasting effects. It would be an act of planetary vandalism, a global chemical experiment with a volcano as our unwitting laboratory. There's a curious and little-known fact that helps us understand this global scale. It's an often overlooked aspect of plate tectonics, the great slow dance of the continents we talked about. Did you know that the Earth's mantle contains an enormous amount of water, more than all of our oceans combined? This water is trapped within mineral structures deep inside the Earth. When this water is released by volcanic activity, it's not just in the form of steam. It's a crucial part of the chemistry of the magma itself, lowering its melting point and driving much of the planet's geological activity. The gases from our trash, in a small but significant way, would be interacting with this deep hidden ocean, altering the ancient and fundamental chemical processes of the Earth. It's a reminder that our world is not a simple machine, but a deeply interconnected web of systems where a single action in one place can have a domino effect on another, from the deepest rock to the highest sky. This raises a profound philosophical question that scientists still grapple with. To what extent are the Earth's systems truly resilient, and to what extent are they fragile? Are we, in our modern hubris, fundamentally misunderstanding the delicate nature of the planet we inhabit? We have a tendency to think of ourselves as separate from nature, as if our actions only affect a local environment. But the truth is, we are part of it all. Our breath is the Earth's breath. The water we drink is the same water that flows through its systems, and the trash we create would, through the mouth of a volcano, become part of a new kind of planetary breath, a poisonous whisper that travels on the wind, a lasting memorial to our inability to coexist in harmony with the natural world. The volcano would not be a solution. It would be a messenger carrying our pollution to every corner of the globe. And the echoes of this act would be heard in the very air we breathe. Our journey has taken us from the molten heart of the earth to the highest reaches of our atmosphere, tracing the path of a single plastic bottle. But let's step back for a moment and consider a different kind of waste. Not the synthetic, but the electronic. The world is filled with discarded phones, computers, and tablets. These devices, which we see as simple tools, are in fact miniature chemical warehouses. They contain a whole periodic table of elements from silicon and carbon to rare earths, heavy metals like lead and cadmium, and precious metals like gold and silver. When we imagine dumping this e-waste into a volcano, we're not just introducing new compounds. We are creating a new chaotic alchemy that would have its own set of devastating consequences. The first thing to understand is that the metals inside these devices don't just melt into a harmless puddle. The melting point of lead is about 327 degrees Celsius, but the melting point of silicon is over 1400 degrees Celsius, and tungsten, a common metal in electronics, melts at an astonishing 3,422 degrees. A typical volcano's magma chamber might range from 700 degrees to 1200 degrees, a vast and terrifyingly hot range, but one that is not uniformly hot enough to melt everything. The materials that do melt would begin to combine in unpredictable ways, and the materials that don't would be forever altered their chemical structures, broken down, and reformed into something new. This is a crucial concept in chemistry, the conservation of mass. Matter is not created or destroyed. It is only changed. Our trash, even in a volcano, would not simply cease to be. It would be transformed into new substances, some of which would be far more dangerous than their original form. The heavy metals, in particular, would be a source of profound concern. Lead, cadmium, and mercury are all incredibly toxic, and they are common components in our electronics. When subjected to the immense heat of a volcano, these elements would not stay locked in their solid form. They would vaporize, becoming gaseous and rising with the volcano's natural plume. This would create a new kind of toxic rain, where these heavy metals would fall back to Earth, contaminating soil and water tables. These aren't just a passing problem. Heavy metals are known to persist in the environment for centuries, if not millennia. They would enter the soil, be absorbed by plants, and from there make their way into the food chain. This is a subtle and insidious form of pollution, a quiet poison that works its way through an ecosystem, weakening and sickening it from the inside out. There's an interesting and little-known fact that demonstrates the Earth's own natural process of handling and moving these heavy metals. In some rare cases, geologists have discovered natural gold deposits in volcanic rocks. This happens when hot mineral-rich fluids, often with sulfur, circulate through the Earth's crust, dissolving trace amounts of gold and then depositing it in a concentrated form. It's a slow, patient process, a kind of natural geology that works on a timescale we can barely comprehend. The Earth in its own way is an alchemist, but it works with natural elements and with a kind of quiet precision. We, by contrast, would be a brute force alchemist, throwing a chaotic mix of elements into the planetary furnace without any understanding of the results. We would be creating new compounds with no natural counterpart, releasing toxins that the Earth has no mechanism to process or reintegrate. This raises a fascinating question, both scientific and philosophical. Where does our responsibility lie? Does it end when we throw something away, or does it follow that object into its future, no matter where it goes? The truth is, we are inextricably linked to the consequences of our actions. The things we create, the things we throw away, are not just our own problems. They are now a part of the planet. By imagining a volcano as a final permanent solution, we are engaging in a kind of hopeful ignorance. We are hoping that the problem will simply disappear, that the Earth's power is so great, it can absorb our mistakes without a second thought. But the Earth is not an endless void. It is a closed system, a single precious sphere. And everything we introduce into it, every chemical we release, every compound we create, will be with us forever. Our journey into the volcano is not a story of ending, but a story of a new and frightening beginning for our waste, one that we would have set in motion and would be unable to stop. We've now touched upon the chemical and gaseous repercussions of our thought experiment, tracing the path of toxins from the deep magma to the high atmosphere. But a volcano's influence and the impact of our pollution does not stop at the edge of the crater. The Earth's systems are all deeply interconnected like threads in a vast global tapestry. What we do in one place, even a seemingly isolated place like a volcanic vent, has ripple effects that can travel far and wide through air and, most importantly, through water. Our trash, reborn as toxic vapor, would not simply drift away. It would become part of the planet's vast and ancient water cycle. Let's trace this path. When the heavy metal vapors and toxic gases from our volcanic plume cool in the upper atmosphere, they would begin to condense. They would mix with the natural water vapor, forming clouds that are not just full of clean water, but of a new man-made poison. This would lead to a new kind of acid rain, one not just made of sulfur and nitrogen oxides, but also laced with dioxins, furans, and heavy metals like mercury and lead. This rain would fall indiscriminately across continents and oceans, far from the site of our initial act. It would be a silent and insidious form of pollution, a constant low-level poison that settles onto our forests, our farms, and our drinking water. This brings us to a critical concept in environmental science: biomagnification. We mentioned bioaccumulation earlier, the process by which toxins build up in a single organism's tissues over time. Biomagnification is the next, more terrifying step. It's the process by which the concentration of a toxin increases as it moves up the food chain. Imagine a tiny plankton in the ocean absorbing some of the heavy metals from this new toxic rain. A small fish eats many of these plankton, and the concentration of the toxin in its body becomes higher. A bigger fish eats many of those small fish, and the concentration becomes even higher still. By the time a large predator like a tuna or a shark consumes many of these bigger fish, the concentration of the toxin can be millions of times higher than it was in the initial environment. The final destination of many of these toxic compounds would be our oceans, which are the largest, most powerful part of the Earth's circulatory system. The oceans are a global sink, a place where all of our planet's excess, all of its pollution, eventually collects. The currents of the ocean would act as a great slow-moving conveyor belt, carrying these pollutants to every corner of the globe, from the pristine Arctic to the deepest, most remote trenches. We often think of our oceans as vast and infinite, but they are not. They are a finite and delicate system that is already under immense stress. By adding our volcanic pollution to this system, we would be crossing a new dangerous threshold, introducing a kind of slow systemic poisoning that would affect the very foundation of the marine food chain. There's a fascinating and little-known scientific phenomenon that reveals the ocean's own unique way of carrying things. It's called the global conveyor belt. This is a massive planet-spanning system of ocean currents, driven by temperature and salinity differences. Warm water at the equator travels north where it cools and sinks, carrying dissolved gases and nutrients deep into the ocean. It then travels all the way to the southern hemisphere before rising and warming again, completing its cycle. It's an incredibly slow process, taking hundreds of years to complete a full circuit. By introducing our pollutants, we would be feeding them directly into this ancient, powerful system, ensuring that our pollution would be with us for centuries, if not longer. Our initial act of dumping into a volcano would, in effect, be a global act of poisoning, a crime against the very systems that sustain all life. This raises a deeply philosophical question about the nature of a solution. We seek quick, elegant answers to complex problems. We want to believe that there is a single powerful act that can make our problems disappear. But the universe and our planet doesn't work that way. There is no magic trick, no great fiery mouth that can simply erase our mistakes. Our planet is a system of interconnected, delicate parts, and every action we take has a reaction. The volcano, far from being the solution, would be a magnifying glass, taking our small local problem of waste and magnifying it into a global catastrophe. It would force us to confront a humbling truth. Our problems are our own, and they cannot simply be wished away or offloaded to some distant geological process. The consequences of our actions, like the echoes of a bell, will continue to ring out long after the initial sound has faded. Our minds have now traveled through the chemical and atmospheric consequences of our thought experiment. We've seen how a single plastic bottle, a forgotten computer, or a discarded battery can be transformed by the volcano into a global poison, but we have yet to truly grasp the scale of the problem. We've been talking about a few pieces of trash, but the reality is far more overwhelming. The human world produces an almost incomprehensible amount of waste every single day. The sheer volume is a weight that we must consider, not just in terms of its toxicity, but in terms of its physical presence. It is a weight that, if introduced to the delicate systems of the Earth, could have consequences that are both physical and geological. Let's try to wrap our minds around the scale. Every year, humanity produces more than 2 billion tons of municipal solid waste. That's a number so large it's almost meaningless. To give it some context, imagine all of the waste produced by every single person on Earth in a year. That pile would be enough to fill over 800,000 Olympic-sized swimming pools. Now imagine a single volcano. Even the largest volcanic craters are just tiny pinpricks on the surface of our planet. They are not bottomless pits. They are geological features with a finite capacity. To try and dump even a fraction of our annual waste into a volcano would be like trying to empty an ocean with a teaspoon. The logistical problem alone is insurmountable, but the physical consequences would be even more severe. This brings us to a fundamental concept in geology and physics: isostasy. Isostasy is the principle that the Earth's crust is in a state of gravitational equilibrium. Think of it like a giant raft floating on a thick viscous liquid. The raft, or the crust, floats at a height that depends on its density and thickness. When we add a massive weight to a part of the crust, like a huge glacier, the crust beneath it will slowly sink. When the weight is removed, the crust will slowly rise back up, a process called isostatic rebound. We see this happening today in places that were once covered by ancient ice sheets. Our trash, if we could somehow manage to pile it all into a volcanic crater, would be a new, unnatural weight. It would be a foreign geological deposit, a man-made mountain of refuse pressing down on the Earth's crust. The problem is not just the weight of the trash itself, but the way it would behave. As we discussed, the trash wouldn't just vanish. It would react, melt, and vaporize, but a huge amount of it would be left behind. This is where we introduce a new horrifying kind of geological formation. We would be creating a new man-made type of rock, a grotesque amalgam of melted plastic, metal slag, and other toxic byproducts. This new rock, dense and unnatural, would settle into the volcanic vent, slowly plugging it up. A volcano is a safety valve, a release point for the immense pressure building up within the Earth's mantle. By plugging it with our waste, we would be essentially creating a planetary pressure cooker. The pressure would continue to build up beneath the surface, with no easy way to escape. There is a strange and beautiful geological fact that illustrates the immense, slow power of this process. Did you know that the Hawaiian Islands are not just random volcanoes, but are part of a chain created by a single hotspot in the Earth's mantle? As the Pacific Plate slowly moves over this stationary hotspot, new volcanoes are formed, and the old ones move away and become dormant, slowly eroding back into the sea. The entire chain, from the active volcanoes of the Big Island to the ancient submerged seamounts far to the north, is a testament to the slow, relentless movement of our planet's crust. This is a process that takes millions of years. Our act of dumping would be an impatient, violent intrusion into this quiet, long-term dance. We would be forcing a geological change on a timescale that is completely out of sync with the natural world, with consequences that would be far-reaching and entirely unpredictable. This raises a deeply humbling question. Do we, as a species, truly understand the forces we are dealing with? We have a tendency to think of ourselves as powerful, capable of manipulating the planet to suit our needs. But in the face of a volcano, in the face of the immense, slow power of isostasy, we are incredibly small. Our problems, our trash which seems so huge to us, are just a tiny momentary blip in the Earth's long history. But our attempts to solve them in a thoughtless, reckless way could leave a scar that lasts for millions of years. The volcano is not our trash bin. It is a monument to a power we do not possess and a process we do not fully understand. And in the face of that, we must learn a kind of humility, a quiet respect for the world we inhabit. We've considered the scale of our waste and the physical weight it would place upon the Earth's crust. We've imagined our trash becoming a new, unnatural kind of stone, a grotesque amalgam of our modern lives. But the consequences of this act would not just be local. Our intervention would reach far deeper, touching the quiet, humming heart of the planet itself. To understand this, we must shift our focus from the crust to the deep interior, a place of silent, immense pressure and heat. We must contemplate the delicate equilibrium of the mantle, the very engine of our planet's life. The Earth's mantle is a world of its own, a vast, slow-moving ocean of rock that is not quite solid and not quite liquid. It is a place of unbelievable heat and pressure, and within it all the elements of the Earth are in a state of delicate balance. The immense pressure keeps much of the rock in a dense, solid form, but the extreme heat means that over geological timescales it can flow. This slow churning motion is what drives plate tectonics, what moves our continents, and what ultimately gives rise to volcanoes. It is a continuous quiet process, a kind of planetary rhythm that has been going on for billions of years. This brings us to a fundamental concept in both physics and geology: convection. Convection is the movement of a fluid. In this case, the mantle's rock, caused by heat transfer. Hotter, less dense material rises, and cooler, denser material sinks. This is the same principle that makes a pot of water boil, but on a scale of thousands of kilometers and a time scale of millions of years. It is a slow, powerful churn that is the very engine of our planet. This convection is what carries the immense heat from the core of the Earth to the surface, and it is a key part of what makes our planet a living, active world. The entire system is in a state of delicate equilibrium, a kind of planetary dance where every element, every temperature, and every pressure has a role to play. Now let's reintroduce our trash. Our hypothetical mountain of waste, a mixture of melted plastic slag and toxic metals, would not simply sit on the surface. Some of it would be drawn down into the mantle itself. This new foreign matter, with its unique chemical composition and density, would be a new variable in this ancient equation. It would be a kind of impurity in the mantle's slow, elegant flow. The presence of these new materials, particularly the heavy metals, could alter the density of the mantle in unexpected ways. It could change the way heat is transferred from the core, disrupting the slow, steady hum of convection. It could create new unpredictable pockets of heat and pressure, leading to more frequent or more violent eruptions in the future. We would be, in effect, throwing sand into the gears of the planetary engine. There is a fascinating and little-known fact that hints at the scale of this problem. Geologists have found that certain hotspots in the Earth's mantle, like the one that created Hawaii, are not always stationary. In some cases, they have been found to have jumped or moved over geological time. The precise reasons for this are a subject of ongoing debate and scientific mystery. It's a reminder that even the deepest, most fundamental processes of our planet are not fully understood. We are observing the world from the outside, inferring what's happening from seismic waves and surface observations. But we cannot truly see the slow churning chaos that is the Earth's mantle. By introducing our waste, we would be, in effect, making a guess in the dark, a reckless experiment on a scale we cannot comprehend. This raises a quiet philosophical question that reaches to the heart of what it means to be a conscious species on a living planet. Is there a line we should not cross, a place we should not touch? The Earth's mantle is a place of incredible humbling power, a source of life and destruction. It is not our personal dumping ground. Our attempt to use it as such is an act of profound disrespect for the very forces that created and sustain our world. It is a testament to our profound ignorance of the quiet, unseen architects of our home. And in the face of such a vast and powerful unknown, perhaps the wisest course of action is to simply listen, to watch, and to learn, rather than to carelessly intervene. Our journey has taken us to the very heart of the Earth, contemplating the delicate balance of its slow-moving mantle. We've considered how our intervention, the addition of our synthetic waste, could disrupt the planetary rhythm. But let's step back from the deep interior and look at a different kind of consequence, one that is less about physics and more about time itself. The Earth, in its great slow geological way, keeps a record of everything that happens on its surface. It writes a history in stone, a silent chronicle that tells the story of climates, species, and eras. By dumping our trash into a volcano, we would be leaving a permanent, unnatural scar in this record, a testament to our brief and reckless existence. Geologists and archaeologists read the Earth's history by looking at the layers of rock. The principle is simple: the oldest layers are at the bottom, and the newest layers are at the top. This is known as the law of superposition. These layers, or strata, are like the pages of a book, each one telling a story about a different time. They record everything from ancient floods and volcanic eruptions to the tiny fossils of organisms that lived and died millions of years ago. The Earth's geological memory is vast and long, a tapestry woven over billions of years. It tells the story of the rise of mountains, the shifting of continents, and the coming and going of ice ages. Now imagine our melted plastic, our amalgam of heavy metals and other toxic byproducts. This new man-made rock would be a foreign object in this natural history. It would be a layer, a thin line of unnatural material, a chemical signature that is entirely out of place. It would be a kind of geological graffiti, a message from us to the future that says, "We were here and we left a mess." This layer would be a permanent mark, a geological anomaly that would last for millions of years. It would tell a future civilization or a future life form that something strange and chaotic happened on this planet, something that did not fit into the quiet, patient rhythm of the Earth. There's a fascinating and little-known scientific paradox that touches on this idea of geological memory. It's called the Novikov self-consistency principle. It's a theoretical concept in physics that suggests that if time travel were possible, it would be impossible to create a paradox that is a situation where an event that is supposed to happen doesn't, or vice versa. Everything in the universe, past and future, is self-consistent. The idea of us leaving a permanent, unnatural scar on the geological record feels a bit like a reverse paradox. It's an act that fundamentally changes the future by altering the past, not through time travel, but through a kind of geological time travel. We are reaching into the deep, slow-moving future and leaving a mark that says, "We broke the natural order." The Earth, in its slow, patient way, would absorb this change, but it would not forget. This raises a quiet philosophical question about our legacy. What will we be remembered for? Will it be our art, our science, our poetry, or will it be our trash? Our actions, even the ones we think are invisible, leave a mark. The Earth is a silent witness, a patient recorder of everything we do. The volcano, far from being a place to erase our problems, is a place where we would make them permanent, where we would write our mistakes into the very fabric of the planet's history. And that is a humbling and terrifying thought. It reminds us that our story is not separate from the Earth's story. It is a part of it, a brief chaotic chapter in a vast and ancient book, and we must choose carefully what we write on its pages. We've now contemplated the geological memory of our planet and how our trash would become an unnatural layer in the Earth's ancient story. But let's zoom out again from the quiet layers of stone to the great slow dance of the continents. We've talked about the mantle's quiet hum, but that hum is what powers the most dramatic geological process on Earth plate tectonics. The Earth's crust is not a single solid shell, but a mosaic of huge, slow-moving plates that are constantly interacting with each other. Our volcanoes, those great all-consuming mouths, are often found at the boundaries of these plates in the places where the Earth's surface is being born or consumed. Think of the Earth's tectonic plates as massive slow-moving rafts on the viscous sea of the mantle. They collide, they pull apart, and they slide past each other, creating earthquakes, mountain ranges, and, of course, volcanoes. The places where they pull apart are often called divergent plate boundaries. Here, the mantle wells up, creating new crust and new volcanic activity. The places where they collide are called convergent plate boundaries, and here, one plate is often forced beneath another in a process called subduction. This is where some of the most powerful volcanoes are found. The subducting plate, carrying its cargo of rock and water, is forced deep into the mantle where it melts and becomes a new source of magma. Volcanoes, then, are not just random holes in the ground. They are a crucial part of this global system, a natural pressure release for the immense forces at work beneath our feet. They are the vents, the exhaust pipes of the planetary engine. They are a sign that the Earth is a living, active world, constantly recycling and renewing itself. And our trash, if we were to introduce it into this system, would become an unwelcome partner in this slow-motion dance. It would be a foreign object in a system that has been working with the same natural materials for billions of years. Imagine our melted plastic and metal slag, our new kind of rock. It would not simply sit there. As the plates move and the pressure builds, this new unnatural material would be drawn down into the subduction zones. It would be carried deep into the mantle where it would begin to melt and interact with the natural magma. This is where the chemistry becomes truly unpredictable. We are introducing elements that have no place in the natural process. Elements like lead-cadmium and all the rest of the chemical alphabet in our modern devices. These would not simply be integrated. They would create new compounds, new gases, and new pressures that could fundamentally alter the chemistry of the magma. There's a fascinating and little-known fact that highlights the quiet power of these deep earth processes. Geologists have discovered that diamonds, those symbols of purity and permanence, are often formed in the deep Earth's mantle and are only brought to the surface by a specific type of volcanic eruption known as a kimberlite eruption. These are incredibly fast, violent eruptions that shoot magma and the diamonds within it up to the surface in a matter of hours. The diamonds, which are just pure carbon, are a testament to the immense pressures and temperatures of the mantle. Our trash with its chaotic chemistry would be the opposite of a diamond. It would be an impurity, a disruption, a source of new and unpredictable chemical reactions. It would be a chaotic shadow in a world of quiet and orderly creation. This raises a quiet philosophical question about the nature of order and chaos. The Earth, in its great slow way, is a system of immense order. It recycles it, renews it, builds, and it tears down all in a kind of elegant geological ballet. We, with our modern lives and our endless production of waste, are a source of chaos. We create things that do not fit into the natural order, and our attempt to throw them into the Earth's systems is an act of profound ignorance. The volcano is not our savior. It is a mirror reflecting our own disorder back at us, showing us that our problems cannot be so easily discarded. We are not feeding a planetary mouth. We are poisoning its heart. Our journey has taken us from the deep churning heart of the mantle to the quiet dance of the tectonic plates. We've come to understand that the volcano is not an isolated phenomenon. but an integral part of a vast, interconnected planetary system. But this system doesn't just exist on land. The majority of our planet, over 70%, is covered by water, and beneath that water, a hidden world of volcanic activity is at play. To truly understand the full scope of our thought experiment, we must descend into the silent, cold depths of the ocean and explore the role of submarine volcanoes. The idea of a volcano under the sea might seem strange at first, but it is a core part of the Earth's geology. The mid-ocean ridges, for example, are a global system of underwater mountain ranges that stretch for tens of thousands of kilometers around the planet. These are the places where the tectonic plates are pulling apart and new crust is being created. Here, magma rises from the mantle, creating new seafloor in a constant, slow-motion process. These deep-sea volcanoes, often known as hydrothermal vents, are a window into the Earth's inner workings, a place where superheated mineral-rich water is spewed into the cold, dark ocean. They are also home to some of the most bizarre and resilient life forms on Earth, which, as we discussed earlier, live through chemosynthesis, drawing their energy not from the sun, but from the raw chemical power of the planet. Now imagine our toxic man-made rock from our volcano on land being carried by the ocean currents. What happens when this new foreign matter, this collection of heavy metals and synthetic compounds, makes its way to the ocean floor? The hydrothermal vents are a system in a delicate balance where specific minerals and elements are recycled in a closed loop. The introduction of our new man-made pollutants would be a profound disruption. The heavy metals would become a part of the water spewing from the vents, creating new toxic mineral deposits. The organic pollutants, like dioxins, would be taken up by the chemosynthetic organisms, poisoning the very foundation of these unique ecosystems. We would be, in effect, poisoning a world we have only just begun to discover. There's a curious and little-known scientific fact that helps to illustrate the quiet, long-term power of this process. Geologists have found ancient preserved deep-sea vents on land in places like Cyprus and Oman that were once at the bottom of a prehistoric ocean. These are called ophiolites, and they are a kind of time capsule, a preserved slice of what the ancient seafloor looked like. By studying the rocks and minerals in these ophiolites, we can learn about the chemical composition of the ancient oceans and the life that existed there. If we were to dump our trash into a volcano, a future civilization or a future geologist might find our strange man-made rock in a future ophiolite, a permanent, unnatural marker of our time on Earth. It would be a testament to our recklessness, a scar in the ancient and beautiful history of the Earth's oceans. This raises a quiet philosophical question about the nature of our impact. Does our influence only exist on the surface in the places where we live and work, or does it reach down into the hidden, unknown parts of our world? The truth is, our influence is everywhere. The plastic we throw away ends up in the deepest ocean trenches, and the pollutants we create travel on the wind to every corner of the globe. The volcano is not a separate entity. It is a part of a vast interconnected system that includes the oceans, the atmosphere, and the very core of our planet. By trying to solve our trash problem with a volcano, we are not just creating a local disaster, we are poisoning a global system, a system that has been in a state of delicate balance for billions of years. And in the face of such a beautiful and complex machine, perhaps the only wise course of action is to tread lightly. We've journeyed deep into the planet's core and under its oceans, and we've come to a greater understanding of the interconnected nature of its systems. We've seen how our trash, far from being erased, would be transformed into a new kind of geological and chemical problem. Now let's consider our initial hope, the very human desire for our problems to simply disappear. The idea of a volcano as a final destination for our waste is at its heart an attempt to reverse a fundamental law of the universe. It is a futile fight against the relentless quiet tide of a principle that governs everything, from the largest galaxy to the smallest particle. That principle is entropy. In the simplest of terms, Entropy is a measure of the disorder or randomness in a system. The second law of thermodynamics states that in any isolated system, entropy can only increase over time. Think of it this way. If you drop a handful of marbles onto the floor, they will scatter. The chances of them landing in a neat, orderly line are so small as to be practically zero. The marbles in their scattered state have a higher entropy, a higher degree of disorder. This is the natural tendency of the universe. Things tend to fall apart, to become more disordered, more random. A volcano, that churning, chaotic crucible, is a perfect illustration of this principle. It takes an ordered system like a solid piece of rock and breaks it down into a disordered system of swirling liquids and gases. Our trash, with its neat, ordered molecular structures, is a temporary local act of defying entropy. We take raw materials and use energy to create a very specific low-entropy object, like a plastic bottle or computer. But when we throw that object away, the universe begins its slow, quiet work of increasing entropy again. The plastic bottle begins to break down, the computer rusts and degrades. The volcano, in this sense, is not our ally. It is entropy's great champion. It would not erase our trash. It would simply accelerate the process of breaking it down into a more disordered, more chaotic, and ultimately, more dangerous state. It would take our organized waste and turn it into a disorganized, toxic plume of gases and heavy metals. There's a fascinating and little-known paradox that touches on this idea of information and entropy. It's called Maxwell's demon, a thought experiment from the 19th century. Imagine a tiny demon that can sit in a doorway between two rooms, each filled with gas at the same temperature. The demon can open and close the door, sorting the fast-moving hot gas molecules into one room and the slow-moving cold molecules into another. In doing so, it would be creating order or decreasing entropy in a closed system, seemingly violating the second law of thermodynamics. While this is just a thought experiment and has since been resolved by physicists, it highlights the deep, quiet mystery of entropy. It is a law that is so fundamental to the universe that even the smallest, most clever demon cannot truly defy it. Our attempt to throw our trash into a volcano is an act of trying to defy this law on a planetary scale. We are attempting to make a problem disappear, but in reality, we are simply turning one form of disorder into another, more insidious one. This raises a quiet philosophical question about the nature of our place in the universe. Are we, in our constant creation of ordered low-entropy things, like computers and plastic bottles, a kind of temporary local anomaly in a universe that is relentlessly moving towards greater disorder? And is our trash a physical manifestation of that struggle, a kind of entropy tax that we must pay for our existence? The volcano, in its great quiet wisdom, would not be our servant. It would be our teacher. It would show us that the universe is not a place of neat, tidy solutions. It is a place of constant, relentless transformation. And our problems, like everything else, cannot be erased. They can only be changed, and it is our responsibility to guide that change in a way that does not poison the world we inhabit. Our journey has taken us from the deep, churning heart of the earth to the quiet philosophical principle of entropy. We've come to understand that the volcano is not a solution, but a catalyst for a new, more insidious kind of chaos. We've traced the path of our pollution from the magma to the ocean, but there is one final and perhaps most beautiful leg of this journey that we must take. We must follow the journey of the volcanic ash and gas, not just as it pollutes our atmosphere, but as it travels to the highest reaches of the sky, creating a new man-made sky that would carry our story to every corner of the globe. When a volcano erupts, it doesn't just spew lava. It also releases a massive plume of ash and gas that can reach incredible altitudes, sometimes stretching far into the stratosphere. This is the volcano's breath, a powerful exhalation that has been a part of the Earth's life for billions of years. These plumes, with their clouds of dust and sulfur dioxide, can have a profound effect on our planet. They can block sunlight, leading to a temporary cooling effect, and they can create beautiful, vibrant sunsets as the dust particles scatter the light. But our trash, if we were to introduce it into this process, would create a new kind of plume, a new kind of sky, and a new kind of legacy. This brings us to a beautiful and powerful concept in atmospheric science: aerosols. Aerosols are tiny particles suspended in the air, things like dust, pollen, and salt from the sea. They are a natural part of our atmosphere, and they play a crucial role in the formation of clouds and the balance of our climate. But the aerosols from our volcano-fueled trash would be something new entirely. They would be a toxic mix of heavy metals, fine plastic particles, and other chemical byproducts. These new man-made aerosols would be carried on the high-altitude winds, creating a global man-made veil that would slowly settle over the entire planet. It would be a permanent toxic addition to the atmosphere, a constant source of pollution that would fall back to Earth in a fine, quiet rain. There's a fascinating and little-known scientific phenomenon that hints at the scale of this problem. Geologists have found that volcanic ash from a single eruption can be found in ice cores from thousands of miles away, preserved in the ancient layers of ice. These ash layers, called tephra, are a kind of natural timestamp, a geological marker that tells us exactly when a volcano erupted. Our new toxic plume would create a new kind of tephra, a layer of unnatural man-made particles in the ice, a permanent scar in the ancient record of the Earth's climate. It would be a testament to our brief chaotic time on this planet, a quiet and chilling message left for future generations. This raises a quiet philosophical question about the nature of our legacy. What will we leave behind? Will it be our great monuments and our works of art, or will it be a layer of toxic dust in the ancient ice? Our desire to solve our problems by making them disappear is a kind of profound denial. We want to believe that we can have a clean slate, a fresh start. But the universe does not work that way. Every action has a consequence, and every object we create, every piece of trash we throw away is a part of our story. The volcano, far from being a place to erase our past, would be a place where we would make it permanent, where we would write our mistakes in the very air we breathe and in the ancient ice of our poles. And in the face of such a vast and humbling truth, perhaps the only wise course of action is to tread lightly, to create with care, and to accept the weight of our own existence. We have followed the journey of our trash from the deep magma to the high atmosphere, from the ocean floor to the ancient ice. We've come to understand that the volcano is not a solution, but a profound and dangerous transformation. But there is one final and perhaps most subtle consequence that we must contemplate. It is a concept that is less about physics and chemistry and more about the quiet, slow, and often invisible way that our actions would have an effect over vast stretches of time. It is a concept that a philosopher might call the slow violence of a stone. The term slow violence was coined to describe a kind of violence that is not sudden or spectacular, but is instead gradual and insidious. It is the kind of violence that is inflicted over years, decades, or even centuries, the kind of violence that is often out of sight and out of mind. A volcano, in its own way, is a kind of slow violence. It is a slow, quiet process that builds up over millennia and then releases its power in a moment of spectacular destruction. But our trash, our man-made pollutants, would introduce a new kind of slow violence into the system. Imagine our man-made rock, our grotesque amalgam of melted plastic and metal slag sitting in the heart of a volcano. Over geological time, this new unnatural material would be a source of constant, low-level pollution. As the volcano hums and breathes, it would slowly release trace amounts of toxic gases and heavy metals. This wouldn't be a sudden plume, but a constant quiet whisper of poison that would seep into the ground, the water, and the air. It would be a kind of slow-motion poisoning of the planet, a chronic illness that the Earth would suffer for millions of years. This is the slow violence of our stone. It is a violence that is so slow, so quiet, that it is almost impossible to see, but its effects would be profound and lasting. There's a fascinating and little-known paradox that touches on this idea of time and violence. It's called the observer effect in physics, the idea that the act of observing something can change it. In the quantum world, this is a literal truth, but in our world, it is a kind of philosophical truth. Our act of looking at a problem, of observing it, and attempting to solve it fundamentally changes the nature of the problem. We want to believe that we can solve a problem by making it disappear, but in reality, we are just changing its form. The slow violence of our stone is a testament to this truth. Our attempt to solve our trash problem with a volcano would not make it disappear. It would just change it into a new insidious problem that would haunt the planet for 1,000,000 years. The problem would still be there, but it would be hidden quiet and out of our sight. This raises a quiet philosophical question about the nature of a solution. What does it mean to truly solve a problem? Does it mean to make it disappear, or does it mean to transform it into a new, more manageable form? The truth is, the universe doesn't have a delete button. Everything is a process of transformation. Our trash, our waste, is a part of that process. Our attempt to throw it into a volcano is an act of profound impatience, a kind of denial of our own responsibility. The volcano, far from being a solution, would be a magnifying glass, taking our small impatient act and stretching it out over a vast and terrifying timescale. It would force us to confront the fact that our problems, like a stone dropped in a quiet pond, will continue to ripple outwards long after we have forgotten about them. We have spent this long evening traversing the depths of our planet, contemplating the chemical, geological, and philosophical consequences of a single reckless act. We have seen how our trash, far from being erased, would be reborn as a new and insidious kind of poison, a permanent scar on the Earth's ancient body. As we near the end of our journey, let us turn our attention not to the chaos we would create, but to the quiet, patient wisdom of the volcano itself. The volcano is not just a force of destruction. It is a teacher, a silent guide that reminds us of a different way of being, a different way of living in harmony with our planet. The volcano operates on a timescale that is almost incomprehensible to us. Our lives and the lives of our nations are measured in decades and centuries. The life of a volcano is measured in thousands and millions of years. It is a process of slow, quiet accumulation of pressure building up over eons, and then a moment of release. It is a rhythm, a pulse that is in perfect harmony with the Earth's own internal clock. The rocks it creates, the mountains it builds, are not made in a day. They are the result of a patient slow-motion process that has been going on since the dawn of time. This brings us to a core concept in geology that is also a kind of life lesson: uniformitarianism. This is the principle that the same geological processes that we see happening today have been happening throughout Earth's history. The slow erosion of a mountain, the quiet movement of a tectonic plate, the gentle breath of a volcano. These are not new phenomena. They are the same processes that have shaped our planet for billions of years. The volcano, then, is a perfect illustration of this. It is a living, breathing testament to the idea that the Earth is not a static place, but a dynamic, active world that is constantly in motion, constantly transforming itself in a slow, patient way. Our attempt to dump our trash into a volcano is an act of profound impatience. We are trying to force our own fast, chaotic rhythm onto the Earth's slow, patient one. We want a quick fix, a fast solution, a way to make our problems disappear overnight. But the volcano, in its quiet wisdom, would show us that this is not possible. It would show us that the universe does not work on our timetable. It would take our fast-paced, chaotic problems and absorb them into its slow, patient process, but it would not do so without consequences. It would transform our problems into a new long-term legacy of pollution that would last for millions of years. There is a fascinating and little-known natural phenomenon that illustrates the wisdom of this process. Geologists have found that certain deep-sea volcanoes release not just magma, but also tiny diamond-like particles of pure carbon. These are not true diamonds, but they are a testament to the immense pressures and temperatures of the deep Earth and the planet's ability to turn a simple element like carbon into something beautiful and permanent. The Earth, in its slow, patient way, is a kind of master alchemist. It takes the most basic elements and over vast stretches of time transforms them into new and beautiful things. Our trash, with its chaotic mix of synthetic materials, would be the opposite of this. It would be a kind of anti-alchemy, a process that takes ordered, beautiful things and turns them into something toxic and permanent. This raises a final quiet question about the nature of wisdom. What can we learn from the quiet, patient rhythm of the Earth? Can we, as a species, learn to slow down, to be more patient, to be more thoughtful about the things we create and the things we throw away? The volcano, in its terrible beauty, is a powerful reminder that we are not the masters of this world. We are just a part of it, a brief chaotic flicker in its long, patient story. And in the face of such a humbling truth, perhaps the only wise course of action is to listen to the quiet hum of the planet and to learn to live in harmony with its ancient, beautiful rhythm. We have reached the end of our journey. We have stood on the edge of the great fiery mouth of the Earth, and we have descended deep into its ancient churning heart. We have followed the chemical ghosts of our trash as they rose from the magma and drifted on the wind, and we have contemplated the quiet philosophical truths that a volcano can teach us about time, entropy, and our place in the universe. We began with a seemingly simple question, a fantasy born from a desire for a quick and easy solution, and we have ended with a profound and humbling understanding of the interconnected, delicate, and beautiful nature of our planet. The volcano is not a trash bin. It is a teacher, a witness, and a part of the great slow rhythm that has been playing out for billions of years. The true solution to our waste problem, of course, is not to find a place to hide it, but to fundamentally change the way we create and consume. It is a lesson in humility, a lesson in patience, and a lesson in responsibility. It is a reminder that we are not separate from nature, but a part of it. The materials we use, the things we create, and the things we throw away are all a part of a vast interconnected system, and our actions have consequences that will ripple outwards for 1,000,000 years. The volcano, in its terrible beauty, has shown us this truth. It has shown us that there is no away, no place where our problems can simply disappear. There is only here, and there is only now, and there is only the slow, patient work of transformation. We have learned that the Earth is a planet of immense power and profound elegance, but also a place of great fragility. We have seen how our attempts to force our own chaotic rhythm onto its ancient patient one would have disastrous consequences. We have come to understand that the volcano, in its quiet wisdom, is a messenger, a testament to a different way of being. It reminds us that our problems are our own, and that the solutions to those problems must come not from brute force, but from quiet contemplation and a deep, abiding respect for the world we inhabit. And as we conclude our journey, we are left with a single profound truth. The Earth is not here to serve us. It is here to be our home, and it is our responsibility to take care of it, not just for ourselves, but for all the generations to come, and for the quiet, patient hum of the planet itself. And so we gently begin our ascent, our journey back from the deep heart of the Earth. Let us slowly, quietly leave the image of the churning magma and the high toxic plume behind. We've traveled a long way together tonight, from the deepest rock to the highest sky, exploring an idea that was at its heart a hope for a simple solution. But we found, as we so often do in the quiet depths of science and history, that the truth is far more complex and far more beautiful. The Earth is not a simple machine, but a living, breathing tapestry of interconnected systems, each one a testament to the slow, patient wisdom of time. Now, as you begin to settle, to feel the comfort and the quiet of the place where you are, I'd like to gently ask one last time, where is the place you're staying now? The time in that place at this very moment. How is it flowing? Just allow the sounds of your own space to slowly come back to you. The soft rustle of the night air, the distant hum of the world outside, the gentle rhythm of your own breath. You are home. You are safe. And you are a part of a much larger, much more beautiful story than you could ever imagine. The story of a living planet, a planet that has been quietly, patiently transforming itself for billions of years. And in the quiet of this moment, perhaps we can learn to be a part of that transformation too in a way that is gentle and kind and wise. Thank you for sharing this journey with me. Sleep well, my companion, wherever and whenever you are. Sweet dreams.